Hello student, today we are going to clear doubt of cardiac cycle. Basically in cardiac cycle we have the sequence of event that takes place in completion of one heartbeat, and in one heartbeat there are two sounds, lub and dub. It's not dhak dhak, please note it. Now one more thing, that in this video I'm going to clear the confusion regarding cardiac cycle, which is that if we have learned in our previous classes, and from very childhood we are learning about the working and circulatory system, working of heart and everything. But in that we have studied that after one contraction, means contraction of one chamber, that is followed by relaxation of other chamber, means contraction of one chamber takes place, then relaxation of other chamber takes place. But we are told in this section that both joint diastole happen, okay, both joint diastole happen after the ventricular systole. Arterial systole and ventricular systole, joint diastole happen. So why is it not happening like ways we have learnt in our previous grades? So this is what we are going to deal with in this video, and I'll be telling you about everything. So please make sure you watch till the end, and let's go. So this is the pie chart from where most of the children get confused. See, first let me introduce you to this pie chart. I'm sure that you have been taught by your teacher about this pie chart. It's very important. The 0.1 second arterial systole, 0.3 second ventricular systole, and 0.4 second is the time period for joint systole, and lub and dub takes place as mentioned in this pie chart. I'll be explaining you in detail about this, but let me explain other things regarding this also. Mention here one more thing, that joint diastole is happening, but we are told in previous grades that ventricular systole happens after, ventricular systole is followed by ventricular diastole, and then arterial systole is followed by arterial diastole. But why is it not happening in the pie chart given? You know what, this pie chart is very important as it tells you about everything, every minute detail. Just you have to look it with another eyes, another point of view. The point of view I'm going to give you now. Can you see I have written here joint diastole? So joint diastole is when ventricle and arterial, ventricle and atrium both diastole at the same time, but that doesn't mean that they are not diastoling separately. They both are diastoling separately, and the point you need to note here is ventricle diastole happens just after ventricular systole, and it continues till arterial diastole, so it continues till arterial diastole. This is how you can clarify your confusion. So let me explain you with the whole diagram. You know what, first I'm going to explain you with the help of my trick. Basically you have been told about this whole cardiac cycle in a way they have written in textbooks, but I am telling you so that you can understand and clarify your confusion. So let me tell you first that, and then we'll match that to the textbook. Okay, so let me start with the first one. So mention here that we will start with ventricular systole and then we'll end with arterial diastole, and then that's how I'll explain joint diastole to you. Let's go. Just for the sake of clarification, let me just give you a brief idea about how a heart works. So this is our heart, which has 4 chambers. So basically it's not like that, basically right? So this is lungs, means this is lung. I'm just drawing a schematic over here, and this is our body, this is lungs, and this is the 4th chamber of heart. So basically what happens, this is right atria, this is left atrium we say, or auricle also. This is then right ventricle and left ventricle. So we all know this, the diagram schematic one. Now what happens is, from left atrium, from lungs we get oxygen. So lungs is the site for oxygenation, and then after oxygenation the lungs send the oxygenated blood to left atrium, and then it passes it on to the left ventricle. Afterwards, through aorta, this is then passed on to the blood body parts. body parts. Now this basically lungs to left atrium, oxygenated blood is transferred through pulmonary. Obviously you know that pulmonary vein is there, which is an exception, as vein are usually transferring or transporting deoxygenated blood. Here it's transporting oxygenated blood. Then we have, after this, body actually transfers the deoxygenated blood, which is carbon dioxide rich blood, to right atrium, and then it passes on to right ventricle. Then this right ventricle passes it on to the lungs for oxygenation. Now one more thing you can note here is that blood transfers deoxygenated blood to right atrium. This is by, this is with the help of vena cava, inferior and superior, both vena cava. And then this right ventricle transport it to the lungs for oxygenation. This is through, we all know, right, this is basically pulmonary artery, which is again an exception. It is transporting deoxygenated blood, but it's artery. So this is how, I have just given you a brief just an introduction for this whole circulation, double circulation it is called. So let me just tell you how I can clarify your confusion, then we'll match it with textbook. Let's go. I have already explained you the whole part. Okay, now I'm just taking one part and let me explain you so that you can clarify your doubt. Now here we have ventricular systole. Ventricular systole just mean ventricular relaxation. Now here in this particular thing, you need to note here that all the blood from ventricle is transporting to the, this is pulmonary artery and this is aorta. So basically this is pulmonary vein and pulmonary valve, and this is aortic valve. So all the blood from this ventricle and this ventricle, both of them are getting transported to the arteries, great arteries, right? So this is what is happening right in the ventricular systole, you can mention. Now what happens after ventricular systole? Obviously if it is systoling, then afterwards it will relax, right? Now once the ventricles relax, then what happens is the valve get closed and all the blood is transported to these arteries, great arteries. Okay, now what happens, this relaxation begins after ventricle contracts, and means after ventricle contracts this relaxation happens. This is how in this I have explained you. And after relaxing in this particular thing, or actually I have to say that this relaxation continues until the atria systole happens. So let me explain you atria systole. So just remember that this systole happens, this relaxation, which is diastole, ventricle diastole, happens after ventricle systole, and this continues till atria diastole. Now just ignore here I have written mid to late ventricle diastole. I'll be explaining you about that also, but now just keep it in mind that here when atria are contracting, which means arterial systole is happening, now the diastole of ventria will stop. Okay, so arterial systole is happening. After arterial systole, this is actually contracting, means ventricle diastole is happening, but after this happen, okay, until this is happening it continues, means the relaxation of ventricle continues, but once it has completely given all the blood out, it will close and the contraction will stop. And since the contraction of arteria will stop, then ventricle relaxation will also stop. Then what will happen, we all know, ventricle systole will happen. Again the blood will get transported to this, but the middle portion we have just skipped, which is isometric contraction. In this phase, basically this is receiving all the blood, ventricles are receiving all the blood from atria, and then it is not giving it to this because the pressure is not that much so that it can give it to that. So for that it is building up pressure with the myocardium is pushing the heart and it's building up the pressure so that the pressure could increase here. And then what happens is, now the pressure is higher than these two pressure, so what happens is simply this get transported to these things. This is how after ventricle systole, ventricle diastole happen, then arterial systole happen, and then arterial diastole happen. And you have also noted here that the relaxation of ventricle happens after contraction of ventricle, which is shown in this figure, and this relaxation of ventricle continues till all the blood from artery is transported or is collected in ventricle, which means it continues till this particular thing all the blood is given out, and all the blood is given out to this. Then afterwards it will close, and once it will be closed, this particular ventricle will stop relaxing, and what will happen is they will simply contract. Now let me just give you a brief idea about what do you mean by valve and what happens actually during these valves, closing and opening, the lubbed up sound and all of that. Then we'll match it with textbook. So basically we have two valves in here, and we have two valves, so simply you can think of it as gates. So we have four valves. Basically these two valves are known as AV valves, which is present between artery and ventricle. And these two valves are known as semilunar valves. These valves are connected to pulmonary artery, and this is connected to aorta. So what happens is when the right atrium transfers the blood to right ventricle, this valve open up, and once it has received all the blood, this will close. Similarly, this happens in left atrium and left ventricle as well. Afterwards we have semilunar valve. After this have received all the blood, this will push the blood to the pulmonary artery, or in this case it will push the blood to aorta, and then we'll notice that this valve get open, and once it has pushed all the blood into them, then what will happen is this valve will close. Valve function is just that to transfer all the blood, and once it has transported all the blood, then what happens is it closes the blood and not allow the blood to flow backwards. So that's how it prevents backflow of blood. Now it's time to match what's written in the textbook. Basically we all know that during step 1, which is ventricular diastole. Now I'm starting here with ventricular diastole, which is actually this phase only when the the atrium are contracting, then the mid to late ventricle diastole happens. Okay, so when atria are contracting, then mid to late diastole happen of ventricle. So this was that phase. Now let me explain you what's written in the text. So the first thing is that atrial pressure is greater than ventricle pressure. Obviously that's how the pressure difference, due to pressure difference, atria can transport all the blood to ventricle. And also atrial pressure is greater than, this is arterial pressure is greater than ventricle pressure. This means that the pressure in these two, this particular and this particular, which means aorta and pulmonary artery, the pressure in these two is greater, so that the blood which is collected here is not transporting to here, because the pressure is greater in here and this pressure is not greater. So basically what is happening right now is just the opening is happening, and opening we don't have any sound as such, so opening of just AV valve is happening. This is what is written over here in the step 1, which is mid to late ventricle diastole. AV valve is open, tricuspid or bicuspid valve, and SLV, which is semilunar valve, is closed. So it's closed, right? Now we have the second step, which is isovolumetric contraction. It's contraction, note here it's systole, and we all know that joint systole can never ever happen. So we have noted it. Now in this particular thing, the whole system is contracting, which means no one is relaxing at that time. Atrial pressure is less than ventricle pressure, and arterial pressure is greater than ventricle pressure. So, and also you can note that AV valve is closed and SLV valve, which is semilunar valve, is closed also. So semilunar valve is closed, which means no transferring of blood. The blood is just collected in ventricle and no transferring is happening. And AV valve is closed, which means the sound of lub will be produced, and this is closed from the starting only, so no sound is produced in here. And this sound of lub is produced when the AV valve is closed. AV valve is closed because because we don't want the blood to go backwards. So AV valve is closed and all the blood is collected, so basically the blood is not going into these two. So because the pressure is higher, and since it is not going in these two, this phase is called the isometric contraction. Okay, because the isometric contraction means no one is systoling, no one is diastoling after the contraction of atria. This is what has happened. Now it is back, basically myocardium is pushing it so that it will contract, and after in third phase this will transfer the blood to these two. But now you can note here that these two are just not contracting, which means not transferring the blood. This is compact form, and since it is compact, so basically we can say that it's isometric contraction. One more thing I want you to note, that during the first particular step, mid to late ventricular diastole, 70 to 80% of filling happens due to ventricular diastole, and 20 to 30% filling of blood happen during atrial systole. I have just told you that ventricular diastole, which is ventricular relaxation, happens after ventricular systole, and ventricular systole, which allows 70 to 80% of filling, and this also continues till atrial systole, means until the atria is systoling and contracting, then tab tak 20 to 30% filling happens, and then also it continues till that also. Okay, so ventricular diastole continues from after ventricular systole to until atrial systole. Now the third step is mid to late ventricular systole. So arterial pressure is actually less than ventricular pressure, and arterial pressure is less than ventricular pressure. This allows the AV valves to close and SLV valve to open, which means semilunar valve is open, so it allows the flow of blood into the aorta and pulmonary artery. But in AV valve it is closed. Okay, so AV valve is closed from the second phase only, which is isometric phase, where we have produced a lubbed sound. And to explain you, I'm just using one more diagram, and you can see the arterial pressure is less than ventricular pressure. Okay, atrial pressure is less than ventricular pressure, and also arterial pressure is less than ventricular pressure. So let's see. So as you can see, this is 0 millimeter Hg we have taken just to assume, but the atrial pressure is less than, that's why it's not moving there. Okay, it's not moving backwards into it, and also valve is closed, AV valve is closed. And also you can note here that arterial pressure, which means the pressure in this and particularly this, is it is less than this particular phase in this particular ventricular pressure. So ventricular pressure is higher, therefore it's transporting the blood into these two arteries, great arteries. Now we have particularly the fourth step, which is isovolumetric relaxation, which is we also call joint relaxation, which is the last phase. And as I have told you that arterial pressure is less than ventricular pressure, and arterial pressure is greater than ventricular pressure, and the AV valve is closed and the SLV valve is closed also now. So this will produce the sound of dub. So what I mean by saying arterial pressure is less than ventricular pressure, that means the ventricle is not able to transport the blood to arteria, and the secondly great arteries pressure is greater, so actually it's not backflowing. The ventricle has all transported the blood to arteries. Now they are not backflowing it, so semilunar valve is also closed, and AV valve was closed from second step only. Yes, that's how we have produced the lub sound. No, this is the phase of isometric relaxation, where we have seen the pressure is greater in these arteries, so it's not backflowing. At the same time, arteries have lower pressure, so these are not flowing into this was from the second phase only, and these have gone into these two, so the pressure is higher in these two and it's not coming back because the SLV valve are closed, these two valves are closed. This means that dub sound is produced. Now let me explain the whole thing in just 2-3 minutes. So basically, as you can see, I have written the whole thing in just half page. So basically after atria systole happens, ventricle diastole happen. We all know that after atria will contract, then ventricle will receive the blood, and after the ventricle have received the blood, isocontraction will happen, which means not ventricle is giving the blood to arteries, great arteries, and neither it is giving it back to this, obviously because the valve are closed, and that's how they produce the lub sound in this isometric contraction. After this, the ventricle systole happen, which means ventricle is then pushing the blood out to great arteries, and then isometric volume relaxation happen, which means both of them are relaxed, which means arteries are also relaxed, and both of them, arteries and ventricle, both are relaxed. And in this also you can note that after arterial systole all these things happen, and during all these things arteria is diastoling, which means artery is contracting. And after the ventricle has systole, then ventricle diastole happen, okay, after it has systole, and this ventricle diastole continues till the arteries is systoling, means after arteries is complete systoling, then also it is happening, means jab tak ye kar raha hai systole, then also this is happening, okay, these two are happening. Once it is completed, this is also completed. This is what happens in the whole cycle. I hope I have explained you very well. Let me just clear one more confusion. Let's come to this, okay. Basically this pie chart is very important. As you can see that we have atrial systole for 0.1 second. After atrial systole all these things are happening, during which atria is diastoling only, means relaxing only. So for 0.1 second it is systoling, and 0.7 second, okay, the whole process which is happening right here, it is in the form of relaxed, okay. And then afterwards we have ventricle diastole. Ventricle diastole happens after it has completed ventricle systole, then it will complete diastole also, which means these two happen for simultaneously. But this starts after the systole of ventricle systole, and then it happens like ventricle systole happens, afterwards ventricle diastole happens, and this diastole continues till the arterial systole. So ventricle systole happens after for 0.4 second, this happens for 0.3 second, and 0.4 second joint diastole happen, which means both this and this are contracting, relaxing, and once these two are relaxing, then we have the ventricle diastole also, okay. So in that process we have both these, and that's how I explain you the whole process. Just keep this in mind that we have this particular thing. After atria systole, then the whole atria will diastole for the whole process. After atria systole, this will diastole, and this diastole begins from this after ventricle systole happens, and this continues till ventricle diastole. So once it has diastole, isocontraction happen when love sound is produced. After it will contract and will give all the blood to arteries, and afterwards isovolumetric relaxation happen when dub sound is produced. And in this particular phase joint diastole is also happening, which both of them are continuously in diastole, and this diastole, which means ventricle diastole, is continued till arterial systole, and this arterial systole finishes, then this also finishes, and afterwards we have isometric contraction, again systole of ventricle, and afterwards all volumetric relaxation. This is how the whole process continues until we die, okay. So obviously heart will stop beating once we die. Now this is how I have explained you the whole process. I hope you liked it. One more question is there that I would just like to get through it. The time taken between lub and dub. So I have told you that in 1 second, 0.1 second arterial systole happen. Here the whole artery will systole, and afterwards it will diastole for the whole time. Now once it has systole, then all the blood will be given to the ventricle, and hence the valve will be closed, and hence the lub sound will be produced here. And after this the ventricle will systole, okay. Obviously ventricle diastole is happening, जब तक ये हो रहा है तब तक ये भी हो रहा है. But once it has completed systoling, artery have completed systoling, then ventricle diastole will also get completed, and what will happen is ventricle systole. Ventricle systole will happen for 0.3 second. Afterwards both of them will contract. This will also contract, and this will also relax, and arteria will also relax. And after relaxing for 0.4 second both, then what will happen is arteria will contract, but the ventricle will systole only. I mean ventricle will relax only. I hope you are getting my point. No, just get my words, don't go by my words, actually get my feelings. Okay, now these things happen. This is how the dub sound is produced after the ventricle systole happens. Because the valve is closed, semilunar valve is closed, so dub sound is produced. And once dub sound is produced, you can note here that lub dub sound difference between these two is 0.3 second, which means time taken between lub and dub sound is 0.3, and time taken between dub and lub sound is the whole 0.5 seconds. This is how you have to go clockwise. That's what I have mentioned here, you can note. Now this is how I complete this video. Thank you so much for watching. Bye.